The next type of bond that we're going to look at is going to be a covalent bond. Covalent bonds result when two atoms share electrons, so that way each atom has an octet of electrons in the outermost shell. And we're going to take just a quick look at carbon. So not carbon, we're going to take a quick look at methane. Methane is going to be this molecule right here. It's made up of 1 carbon and 4 hydrogen atoms. So we're going to start off by looking at how many how many electrons carbon and hydrogen have in their valence shell. So we're going to start off with carbon. Carbon over here has an atomic number of 6, an atomic mass of 12, which means that he has 6 protons and 6 neutrons inside of his nucleus. How many electrons does carbon have? Yes, carbon has 6 electrons. So if we were to draw a molecule of carbon, we would draw it with, carbon with a nucleus with 6 positive charges on the inside and 6 electrons or 6 negative charges orbiting it around it. How many electrons are we going to put in the first energy shell? 2. We always put 2 electrons in that first energy shell. Then we're going to set up our second energy shell. How many electrons go in our next energy shell? 4. We can fit up to 8, but there are only 4 electrons left. We started with 6 electrons, we put 2 in the first energy shell, and we have 4 in the next energy shell. This means that if we are going to form an ionic bond, we're going to need to either pick up or drop off 4 electrons. Now this is a lot. That is a lot of electrons to transfer for a single atom. It's going to probably destabilize the nucleus, so we don't really want to pick up or drop off any electrons. So we're going to try and form a slightly different type of bond, and we're going to do this with hydrogen. So let's take a quick look at hydrogen while we're still here at the periodic table. Hydrogen over here has an atomic mass of 1. Has an atomic number of 1. Also has an atomic mass of 1. This is because, for the most part, hydrogen only contains a proton. There's no neutron. For the vast majority of hydrogen does not contain a neutron inside of its nucleus. So inside of our hydrogen atom, we have 1 proton, 1 positive charge, which means on the outside we must have orbiting around 1 negative charge, or 1 electron. So here's the thing with hydrogen. Hydrogen has 1 tiny little electron orbiting around his outside. Now he doesn't really want to give that up. It's his only electron. He doesn't want to really give that up, but he still really wants a completed octet, or he still wants a fully satisfied valence shell. Now because he only has 1 valence shell, he only needs to pick up 1 extra electron in order to be satisfied. So here's what he's going to do. He's going to go over to carbon and make a deal with carbon. He's going to say to carbon, I will share my 1 electron with you if you share 1 of your electrons with me. And carbon goes, okay, that's pretty good. I go from then having 4 electrons in my valence shell to having 5 electrons in my valence shell. That gets me, 1 step closer to 8. Carbon goes, that's a pretty good idea. I'm going to see if I can pull that deal again. So carbon then goes to 3 other hydrogens, and to each one it says, I will let you borrow my 1 electron, so you can have a completed octet, if you let me sometimes borrow 1 of your electrons, so I can complete my octet. And so that's what happens. These electrons are going to orbit around carbon and around hydrogen, and around carbon and around hydrogen, and around carbon and around hydrogen. This pair over here is going to orbit around hydrogen and around carbon, and around hydrogen and around carbon. Same with this pair over here, around hydrogen and around carbon, and around hydrogen and around carbon. So on and so forth. So what happens is that these bonds, these covalent bonds, are formed by the actual sharing of electrons between atoms. So here's our example of methane. This is just the words, so you can have a written version of what I just said. In the example of methane, carbon is going to follow the octet rule. It wants to have 8 electrons in its valence shell, but he's got a long way to go with having only 4. There's a lot to drop off. That's a lot to pick up. So the easiest way to do that without destabilizing or changing the charge of the atom is going to be to just temporarily share. Hydrogen only needs 2 electrons in his outermost shell. So if each hydrogen shares its electron with carbon, the carbon would have 8 electrons in its valence shell. If carbon were to share its valence electrons with each of those 4 hydrogens, every hydrogen would have 2 electrons in its valence shell. And in this way, they can both satisfy their outermost shell or their valence shell. Now, covalent bonds can be formed several different ways. They can be formed between two of the same atom in the case of oxygen. Now, the interesting thing with oxygen is if we're going to take a quick look at oxygen, and we're going to look at its structure. So if we look at oxygen, oxygen has an atomic number of 8, and it has an atomic mass of 16. Now that atomic number of 8 tells us that there are 8 protons in the nucleus, which means there must be how many electrons? Very good. There are 8 electrons orbiting around that nucleus. If we put 2 electrons in the outermost shell, we're going to end up with 6 electrons, 1, 2, 3, 4, 5, 6 electrons in the valence shell. Now here's the thing, 6 electrons is still not a happy octet. So what happens is oxygen is actually going to find another oxygen atom and say, hey, I've got 6 electrons, I want 8, you have 6 electrons, you want 8, what if we just share? I'll let you borrow 2 of my electrons if you let me borrow 2 of your electrons. And they're going to form what is known as a double bond, where we're actually sharing 2 pairs of electrons back and forth between these 2 different nucleuses. So that's going to be an example of covalent bonds. Covalent bonds can be formed by the sharing of 1 pair of electrons, 2 pairs, or even up to 3 pairs of electrons. So we can have double bonds and triple bonds between atoms. So there are actually going to be 2 different types of covalent bonds. There's going to be non-polar covalent bonding and polar covalent bonding. Non-polar covalent bonding happens when there is an equal sharing of electrons. A lot of times this will happen between 2 like-minded atoms. So in the case of hydrogen forming a molecule, so hydrogen forming hydrogen gas, that's when we have 2 atoms of hydrogen bonded together. These electrons are going to spend just as much time orbiting around one nucleus as they are another. So we have some really nice equal sharing going on back and forth and back and forth. The electrons are going to orbit together and spend just about as much time in each or around each nucleus. Now here's the interesting thing. That does not always happen in real life. Those of you who have siblings know that sharing isn't always equal. There is not always going to be an equal sharing of electrons, and when that happens, we see what is formed is going to be a polar covalent bond. In the case of water, we're going to see that we have an oxygen atom bound to 2 hydrogen atoms through covalent bonds. But here's the thing. Oxygen says, hey, I will share one of my electrons with you, hydrogen, if you share one of your electrons with me. But then oxygen gets a little bit greedy, and that pair of electrons is going to spend more time orbiting around oxygen than it is around that hydrogen. So for every couple of rotations we do around oxygen, we're going to do maybe only 1 around hydrogen. Oxygen is not going to share equally, and he's going to do that with both of the hydrogens. Those electrons are going to spend just a little bit more time hanging out with oxygen than they are with hydrogen. And because of this, because electrons have a negative charge, this is going to make the oxygen end of the molecule a little bit negative. This area over here is going to have what we call a partial negative charge. The reason we call it partially negative is because this hydrogen has not given up full custody of his electron. He doesn't completely give it over to oxygen. It just spends more time hanging out with oxygen than it does with hydrogen. And so it's going to be only a partial negative charge, not a full negative, because we haven't donated or accepted an electron. So the oxygen region of water is going to be very slightly negative, and the hydrogen region of the water molecule is going to be very slightly positive. Now, this is going to be really interesting when we start talking about the various characteristics of water. Almost all of the things that are unique about water, all the properties that are unique about water, are due to these polar covalent bonds, this sort of unequal sharing of electrons that creates sort of a charge differential, or an unbalanced charge between these two halves of that molecule. We're going to back up just a minute. I'm going to put everything into words so that way you have a chance to kind of write it down. So polar covalent bonds. Polar covalent bonds are caused by an unequal sharing of electrons. Sometimes one atom is able to attract the electrons to a greater degree than the other atom. We say that this means they are more electronegative. They can attract more of those negative electron charges. This is going to create a polarity, or a partial charge at one end of the molecule. The polarity of the molecule is very important because it affects how molecules interact with one another. And we're going to see that when we spend a little bit of time looking at the chemistry of water and the various characteristics of water in our next video.